All right, welcome back everyone to the second video of the Azure DP-900 Cert Prep course. Today in this video, it's going to be a little bit of a long one. We're going to take about 40-ish minutes to go over data services, data formats, and data storage. If you haven't heard me say this already, I recommend watching these videos at 1.5 speed. Kind of helps it go faster, and also take breaks. Pause the video every now and then, walk around. Yeah, that should help with the memory retention. All right, small tangent. If you haven't seen these objects before, these are basically one of the earliest examples of humans recording data in human history, basically. The top left is something called a hipu. And basically in ancient Mesoamerica, civilizations used these strings and knots to record information on things like taxes, seasons, any numerical information, basically. It's actually a very, very interesting and early example of, just basically the way the human brain works. And on the bottom right, the little fish icon or a fish drawing is actually a cave painting that was found, and researchers essentially discovered that these markings on these animals were basically indicators of when this animal was in season. Of course, they didn't have, calendars or any sort of numerical way of counting dates tens of thousands of years ago, so has something to do with like moon cycles or something along these lines. Anyways, let's actually jump into the Azure. Let's skip this review. We'll actually go over this review during our class. And instead, let's talk about data formats. All right, so data formats. And you'll see exactly what I mean when I talk about data formats. But before we get into that, I want you all to, once again, take a moment, pause this video, and consider the following two questions. Question one, where have we stored our data during the IO Fellowship, and in what format have we stored our data? Question two, what would you say is the difference between a file system, or file storage and a database? Think about those two different concepts. So think about those questions. And once you're ready, let's just keep moving forward. We're not going to discuss the answers to those questions. Instead, hopefully, now that you thought about that a little, these slides will be even more impactful and it will help you actually identify some of the things that you've already been doing. So let's get started with data formats. The three main data formats that Microsoft considers is structured data, semi-structured data, and finally, unstructured data. And here we have three images of those very same concepts. See if you can match up these images to these categories. There is a one-to-one relationship between these things. All right, so first off, let's talk about structured data. Hopefully, you all identified that this row and column format is what we would call a structured data format. And essentially, this is when data adheres to a fixed schema, to a fixed plan. Every single object has the same field or property. A great example of a structured data format is relational data, or even Excel data or CSV data. Basically, anything that has columns and rows, we can call that a structured data format. Of course, it could be possible that we'll have null values here or there, but that does not take away from the fact that it is expected that every single record has the exact same attributes. The null values are considered abnormalities, not necessarily violations of the rule. So yeah, that is what a structured data format is. Next up, everyone, we have something called a semi-structured data format. And just like the name implies, a semi-structured data format basically indicates that there is some structure to the object, but there is variation between entities, right? Maybe some objects won't share the same attributes. Maybe they'll have extra attributes. Maybe they'll have missing attributes. And that's all perfectly within reason of a semi-structured data format. A good example of this would be a JSON data set. And this is what, or pardon me, a JSON object. And this is what a JSON object basically looks like. We'll go over the, in fact, actually, let's go over the details now. So yeah, we call this a JSON object. And a JSON object is basically composed of fields and values, kind of like a dictionary, a Python dictionary, right? Here is the field, here is the value. As you can see, we can have different data types for fields and values, although the fields are always strings. Furthermore, we could have objects inside of objects. As you can see, the curly brackets indicate when we start a new object, and once again, it has its own fields and values. So as you can see, this could get pretty nested. And lastly, we can also have arrays. And arrays are just basically lists, except this time we use the square brackets to indicate our list. So yeah, essentially everyone, this is what a JSON object is. Once again, think of it as a Python dictionary, essentially. And finally, everyone, we have unstructured data formats. And that's essentially when it's the Wild West and data abides by no structure. You're not going to expect brackets. You're not going to expect columns. There is no structure to the data object. This is what we call documents, images, or essentially documents, images, audio, video, and binary data is what we call unstructured data. The only way we can read these data files is if we feed it into a very specific program that's engineered to read these files, right? When it comes to JSON and CSV, a human can read it, right? A human can open and read this table if they truly wanted to. But this, no, this is purely designed for the computer. And once again, called an unstructured data format. Okay. So now that we've gone over data formats, everyone, let's talk about data stores, places where we store these data objects, right? So where do we put our unstructured, semi-structured, and structured data? Well, we either put it inside of a database or a file storage. As you know already, a database is basically only designed for structured data. And this is when we have some efficient software that supports updates, inserts, and deletes. If you all use Postgres, that's essentially a database, although we will talk about different types of databases. And in all clarity, a database could be semi-structured as well, maybe even unstructured too, or rather it could support the storage of those kinds of objects. Next up, everyone, we have a file store. And this is essentially when we have a file system, sort of like your computer, or like an S3 bucket, if you remember your capstone project, where you basically store unrelated data objects. And one important concept, everyone, is that databases build off of file stores. Because essentially, the data that a database holds, that data can actually exist and often does actually exist within a file store. The database just essentially accesses that database or that data. But that's just a nuance that you don't really have to worry about. The most important thing is that you understand the differences between these two concepts. A database is a hyper-specific software that's used for the efficient insertion and updates of data. A file storage, that's just your file system on your operating system. It's a whole bunch of unrelated objects, possibly unrelated objects, on one hierarchical system. There's that word again, hierarchical. All right. We'll go over these review questions during class, although you could tackle them now if you want. Let's move forward to file storage. All right. So, and we'll skip this discussion question for the time being. So let's talk about the different categories of files that you can have in the world of database management, and even I would say data science more broadly speaking, right? So you could have the limited text files, You should be familiar with some of these formats. You could also have JavaScript object notation, which is that JSON object that we just talked about. You could also have extensible markup language, binary large objects, and finally, optimized file formats. For some of these formats, you should already be able to categorize them into structured, semi-structured, or unstructured format, especially since we just named one as semi-structured, right? Anyways, let's dive into the very first category of CSV and TSV files, also known as delimited text files. So essentially, everyone, this is your good old-fashioned CSV. Really nothing new. Everyone knows what a CSV is, a comma-separated file, value file is. And that's essentially, everyone, when we have a plain text file that has certain delimiters, such as commas, tabs, or brackets, and row terminators. It's a good idea to use this data when data needs to be human readable and needs to be accessed across a broad range of applications. This is for when you want to load your data into Pandas, Excel, Tableau, whatever application you can think of, a data application you can think of, it's probably going to support CSV files. And once again, think for a second. Is this a structured, semi-structured, or unstructured data format? The answer is structured. All right. Next up, everyone, we have JSON, and really we just talked about this. This is just JavaScript object notation, a JavaScript object notation file. It's traditionally seen as a semi-structured data format. Next up, we have XML, which stands for Extensible Markup Language. Think of this as basically like HTML, Hypertext Markup Language. This is also considered a semi-structured data format. It's often used in web applications. And also it supports a hierarchical document scheme, much like HTML. And finally, everyone, we have, well, actually not finally, last but second to last, we have something called a blob file, which is essentially a binary large object. And once again, everyone, this is the unstructured data format that's often used to interpret videos or represent videos, images, and other types of binary data. In fact, if you open up a GitHub repository on your computer and you find the .git folder, if you look inside of .git, you will find a whole bunch of blob files. And that's just basically large binary data. This right here, I think it's called blob fungus, if I'm not mistaken, or maybe something else. Anyways, it's some sort of fungus that grows in multiple directions and can actually solve mazes, interestingly enough. All right. Next, everyone, let's talk about, and this is the last data format that we'll talk about for today, or the last category of data formats, optimized file formats. We're going to talk about three specifically: Avro, Orc, and Parquet. The first one is Avro, and you will all get a sense as to why these are specialized data formats, like what makes these different from all the other data formats that we talked about. And even before I get into it, the whole general idea of these specialized data formats, everyone, is that they are much faster and much more efficient than all the other previous data formats that we talked about. Avro specifically is a row-based data format that has a JSON header that describes structure. It's often used, data is stored in binary format, and it's often used for compressing data and minimizing storage and also bandwidth, which is essentially when you send over data. And that's Avro. Next up, everyone, we have Orc, or ORC, which is essentially a column-based format, and we're going to see why that's important in the next few slides. And it's essentially the type of data that's used for read and write operations in Apache Hive, which is a solution that we'll talk about later on as this course progresses. Maybe if we're lucky, we'll even use Hive on Azure. And finally, everyone, and this is honestly, I would say, the most common optimized file format that you'll see, or optimized file storage format that you'll see, Parquet. This is also a column-based format. In fact, I think this was developed at Twitter, if I'm not wrong. And essentially, everyone, what Parquet does is it stores data in chunks, which describe row groups. It's super efficient and supports great compression and encoding schema. And oftentimes, you will be able to save a lot of storage if you convert your CSV files into Parquet files. And why is that? What differentiates these type of column-based files versus row-based files? Well, check this out. Essentially, everyone, there are two types of ways to store data. And while I guess the common sentiment now is that column-based databases and column-based formats are the way to go, and there's no reason why you would ever need row-oriented data formats. I think it's a little bit more nuanced than that. I think just as it is usually, there are different solutions for different problems, right? So just to put a bow on this and to wrap this up, a column-oriented database or column-oriented format, everyone, is hyper-optimized for analytical purposes, whereas a row-oriented database or format is optimized for transactional processes. And we'll talk about what a transaction actually is in the next video. But essentially, think about it like this. Let's say, and we have this table of employees and their employee ID and all their information. Let's say you want to get the average start date or average hire date of each employee. Well, if you were to do that in a row-oriented database, essentially what you would have to do is loop through every single one of these rows, extract the hire date, and basically calculate some sort of average, right? Well, with column-oriented database, it's actually a little bit different. You'll notice that instead of data being stored in a row, entire columns are stored in each row, right? Notice how the employee number column, well, it's stored as an entire row. The department ID column, that's also stored as an entire row. And finally, so is the hire date column. It's stored as an entire row. So if you wanted to calculate some sort of summary statistic on this database, well, all you need to do is extract the entire third row. It's actually a pretty amazing concept. So instead of looping through each row and getting, the data one by one, you can just basically do supposedly one operation to get the column stored as a row. We'll talk about that a little bit more and definitely play around with Parquet files once we get onboarded to Azure. Here's some review questions. I'll probably post these as discussion questions later on. Once again, some of them are a little bit ridiculous, but we'll just keep moving forward. Okay, so I recommend that you take about 5 minutes, pause the video, stand up, do something else other than watch this, get some water, so on and so forth. Because now we're going to talk about something a little bit more involved, the Azure Data Services. All right. So once again, I'm bringing back the data science hierarchy of needs. Obviously, this concept really stuck with me because I keep bringing it back. But you'll see why. It makes sense given the context. So for the DP-900 exam, you need to essentially memorize 12 solutions and their use cases. Here's all 12 of them. Now, instead of me just sitting here and rattling off each solution one by one, Azure SQL, Azure Cosmos, Power BI, super boring. I'm going to do something a little bit more interesting, and we're going to group these solutions into related clusters. In my opinion, I think that's going to be a lot better for memorization. Hopefully, you think the same way. So once again, we have the data science hierarchy of needs. There are different tools for different problems. We need to collect data, store data, export data, aggregate data, learn on data. Each one of these tools, I'm going to skip this example. Each one of these tools applies to some portion of the data science hierarchy of needs. I'm going to create 4 broad categories. The first category is databases, where we store our data, and data stores. The second category is pipelines, things that we use to create ETL pipelines. The third category is analytics, things that we use to create machine learning algorithms and analyze data. And finally, the fourth category is the maintenance of data. And you might be thinking, Farouk, what in the world is data maintenance? Like, what does that even mean? Don't worry, you'll see it's actually really, really simple. Okay. Once again, hierarchy of needs. These different categories apply to different hierarchies. For the purpose of moving and storing data, you got databases and pipelines. And for the purpose of learning and aggregating and exploring data, you have your analytics solutions. And maintenance kind of fits into all of these categories, I would argue. Maybe even data collection. All right, here are your categories. Azure SQL, Azure Cosmos, Azure Storage, and open source relational databases go in the databases category, obviously. Data Factory, Synapse Analytics, HD Insight, Stream Analytics, and Databricks goes into pipelines. Data Explorer, Power BI, and maybe Databricks and Synapse Analytics also go into analytics. And finally, something called Microsoft Purview goes into data maintenance. Now, the next couple of slides, we're actually going to go through each one of these categories and break down piece by piece what this tool is and what the purpose of it is. I'm going to try to go through this as fast as possible, and I'm just going to recommend that you look at the slides yourself to really get a good overview. But we'll still try our best to get a good understanding of these tools, at least an introductory understanding. All right, first up, everyone, is Azure SQL, and this is essentially your classic bread and butter relational databases used in Azure. If you want to store data in a relational database, Azure SQL is probably the way to go, right? The only thing is that there are 3 specific solutions. There's Azure SQL Database, Azure SQL Managed Instance, and Azure SQL VM. Now you might be thinking, well, what's the difference between all these 3 solutions? Well, essentially, as you go down the list, simplicity decreases. So essentially, or in fact, actually, I think a better way to talk about this is that complexity increases, but so does configuration. Basically, think about it like this. And I should draw this arrow going the other way, in all honesty. Let me go. Yeah, sorry, it was a little confusing. As you go down the list, as you get to Azure SQL VM, your complexity is increasing and your configuration is increasing at the same time. So essentially, it's going to take a lot more to set up and manage these tools, but in return, you get greater control and greater power over your tools. So Azure SQL Database starts off as the most simple solution, and Azure SQL VM is the most complex solution. And that is in both terms of work and also configuration. Essentially, Azure SQL Database is just a platform as a service. It's a simple transactional database. You really don't have to do much to get it set up. Whereas Azure SQL VM, well, this is an actual virtual machine. And if you've ever heard of the concept of virtual machine, that's essentially a computer that's like living out in or somewhere out there in Azure's servers, and you basically have to maintain this thing yourself. You need to make sure that updates are good to go. You need to make sure that you've partitioned enough memory, so on and so forth. And that's what we call infrastructure as a service. Now, I understand that you all might not have heard of these terms before, platform as a service versus infrastructure as a service, but we'll go over what these terms actually mean in the next slide. Once again, each subsequent tool increases in configurability, but decreases in simplicity. As you go down this list, you get more control over the solution that you're working with, but in return, things become more complicated. Think about it as like a car, right? Uh, if you just buy an automatic car, transmission is handled for you. You really don't have to worry about anything. Whereas if you buy a manual car, and I hear it's not that hard, but I don't know, the concept still kind of scares me. You're gonna have to do all your, shifting of gears, and maybe you'll have to maintain the engine. I don't know. I'm not a car person. I still take the bus. So yeah, you hopefully can get some meaning out of that allegory. Okay, but in summary, they all provide the same thing: relational data hosting. Everyone loves relational data hosting. All right, and here's everyone essentially the difference between software as a service and platforms as a service and infrastructure as a service. Um, with software as a service, all of these things are being maintained for you. Like when you purchase Tableau, you're not expected to spin up your own server and partition your own data. No, Tableau manages that for you, which is why it's so expensive, right? Whereas in infrastructure as a service, most of the parts you actually manage yourself, which increases the complexity, but some parts are still managed for you, as you can see. Red on red is probably not a good idea. We do green. Look at that, Christmas colors. And finally, everyone, we have something called on-prem or on-premises. Some companies still do this, but honestly, as far as I understand, when you're working in any company at this point, your data management and software tools are going to be handled by some sort of cloud solution at this point. All right, so that, everyone, was Azure SQL. Next up, we have relational databases for Azure. This is just MySQL, MariaDB, and PostgreSQL. Everyone knows PostgreSQL. We use that throughout our fellowship. Really a great tool for hybrid object relational databases. But in all honesty, Postgres, as far as I understand, it can be used for almost anything. I've seen people use Postgres as a graph database. I've seen people use Postgres as a vector database. Really, there's almost nothing that Postgres can't do. So just keep that in mind when you're like on the pursuit for like a new database tool. Do you honestly need a new database tool? The answer might be no. The answer might be Postgres tool. Next up, we have MariaDB and MySQL, both made by the same people. MySQL is often used in Linux, Apache, and PHP applications, also known as LAMP apps. MariaDB, just basically MySQL, but rewritten, and is compatible with Oracle databases. All right, next, everyone, we have Cosmos databases, which is your first NoSQL database. That's pretty wild concept. NoSQL. What does NoSQL mean? Well, you will all find out later this course. And for that reason, I'm not going to spend too much time on it. But here's some types of NoSQL databases: key value, column family, document, and my personal favorite, graph databases. And next up, everyone, and this is the last one for the database portion, is Azure Storage. Now, Azure Storage is essentially your S3 buckets of Azure. It could also be your Google Drive of Azure. It's essentially a way to store blob files and file shares and tables in Azure. It's also used to actually create something called a data lake, which we'll also talk about later. All right, so hopefully you all understand that Azure Storage is your file storage, whereas these solutions, SQL, open source, relational, and Cosmos, those are your databases. Okay, I think I'm going to save mentioning pipelines and analytics and maintenance later for when we actually get to it. because I do not want to overload you all with too many tools. For now, the only thing that I want you all to think about is Azure SQL, Azure Database for open source data, Azure Cosmos, and Azure Storage. That's the only thing you should be worried about for now. When we get to pipelines, analytics, and maintenance, I'll introduce these guys as well. And for that reason, I'm just going to skip through all this. Power BI. I'll briefly mention this. Power BI is really easy. It's just basically Tableau. It's Tableau for Azure. Some people like Power BI better. It is free. I'll give it that. Up to a point, I think. Whereas Tableau is a lot more restrictive. They really, really want you using the premium version, which is a lot of money. All right. Okay. That is going to be it, everyone. Next week, we will talk about more databases and OLTP and OLAP. And yeah, we'll just take it from there. Thank you all so much, and I'll see you in the next video.